Hello everyone, myself Prasanakumar from VSB Engineering College Karur, Assistant Professor in the Department of Civil. Today I am discussed about the topic of Unit 5 of Hydrology and Water Resource Engineering. In this unit, we can give clear knowledge about groundwater and management. In first topic, we see about the origin of groundwater. Groundwater originates entire from the natural water cycle. When the rain falls or snow melts, a large portion of water does not evaporate or run off into the lake. Groundwater originates mainly from precipitation. Rainfall infiltrated into the soil, moves downward toward a porous and fracture that reaches the saturated zone. Next, we see about what are the sources of groundwater. Infiltration of rainwater, seepage from rivers, lake and reservoir, also artificial recharge systems. Next we see about the groundwater is mainly comes from the rainwater. Once the rainwater enter into the soil through the infiltration. Infiltration is a process due to the presence of porous present in the soil or sand particle. Directly rainwater enter into the downward direction of soil. After that water collected below the earth surface. After the collection of water, it can be stored in the underground surface for future uses. It can be used for drinking, farming, and industrial activities. Next, we see about the classification of groundwater based on its sources. There are three different types, namely metotic water, colonate water, and juvenile water. In metotic water, it is the most common type of water that is originated from precipitation in form of rain that is automatically infiltrated into the down surface. Next, we see about colonate water, the Asian water that was trapped in the sedimentary rock when their rot were first formed million years ago. Water is trapped inside the rot for a long time when compared to the other two different types of groundwater. This type of groundwater contains more minerals. Next we see about the types of groundwater. There are four different types of groundwater. Unconfined groundwater, confined groundwater, perched groundwater, semi-confined groundwater. In unconfined groundwater, water is stored at the shallow depth under the atmospheric pressure. The top layer of the saturated area is called water table and it fills drains freely depending upon the rainfall. Water level automatically changes with the rainfall. Next we see about the confined aquifer or confined groundwater. These are the deep underground water bearing layer tapped between the impermeable lot or K layer. The water is under high pressure, meaning it can be raised up in the well or even when tapped. Next we see about the semi-confined groundwater. Water can enter directly move with the partially permeable layer that can be present inside the soil or rock particles. Next we see about the aquifer. Aquifer is an underground layer of water-bearing rock, sand that hold and transmit the groundwater. It acts as a natural sponge and slowly filter and storage of water below the earth's surface. There are seven different properties of aquifers. They are porosity, permeability, hydraulic conductivity, specific yield, specific retention, transmittivity, and storage coefficient. Next we see about the porosity. Porosity it is a percentage of empty space in present in the rock or soil. It dictates the how much water that can be aquifer can store. For an example, mainly finds as high porosity because it contains many holes. Next we see about what is the formula to find out the porosity is total volume of void divided by total volume into 100. Next we see about what is the importance of porosity. It is usually determine the how much water can be stored in a particular type of an aquifer. Next see about the permeability. Permeability defines as the water movement ability. Permeability is the ability of water to flow toward a soil or rock. It is a property that is described how can water can easily move towards between the 2 points. For an example, sand having high permeability due to having presence of pores. when compared to the sand K having low permeability. It is used to determine how easily underground water can move with the help of different types of aquifers. Next we see about hydraulic conductivity. Hydraulic conductivity, it is a measurement of how fast water can move toward the aquifer. It combines the material permeability with the thickness of underground layer. In mainly hydraulic conductivity depend on size of the soil particle, porosity as well as water properties. It is used to calculate the groundwater flow. Next we see about a specific yield. Specific yield is defined as the actual amount of water will be taken out of rock or sediment under the pull of gravity. Otherwise it is defined as the amount of water that an aquifer can release by a gravity. We can, by using this formula, we can directly find out the specific yield. Water drained by total volume into under. Specificity is important because it is used to indicate the usage of groundwater at specified location. Transmittivity is defined as the ability of an aquifer used to transmit the water to the entire full thickness. It is also defined as the overall capacity of an aquifer used to transmit the waters of an entire full thickness. Direct formula can be used to calculate the transmittivity is K into B, where K is an hydraulic conductivity and B is an thickness of an aquifer. There are two different types of transmittivity should be take place, high and low. In high transmissibility means that water can move quickly when compared to the higher transmissibility, lower transmissibility water can move slowly. Then we see about the passive retention. Passive retention is defined as the percentage of water that remains into the rod or solvents even after the gravitational drainage. This water is held tightly by capillary and molecular forces and cannot be pumped out, or otherwise passive retention is defined as the amount of water retained inside the soil after the drainage. The importance of passive retention are source of water held due to the capillary force. Next we see about the storage coefficient. Storage coefficient is tells about the exact volume of water of an aquifer. Releases are data in per unit of surface area for each unit changes in the water level. It is a dimensionless number that dictates how much water an aquifer can yield when pumped, or otherwise it is defined as the volume of water released or sold per unit area for an unit area in a water level. Next we see about the Gaussian equation. It is a mathematical equation used to explain how groundwater moves underground with the help of gravity. This equation tells us whether water goes, how fast it moves, and how much water can flow. Best example is Darcy law. Darcy law is says that the electricity flows from high to low voltage. Water flows underground from the area of high hydraulic head to the area of low hydraulic head. Therefore, it depends directly on how easily it for a water to move to the soil. Direct formula should be calculated with the help of Darcy law is Q is equal to KIA, but Q is a discharge, K is a hydraulic conductivity, I is a hydraulic gradient, and A is a cross-sectional area. Next we see about the continuity equation of groundwater. It is based on the conservation of mass. It is defined as the phase as the rate of water coming in minus the rate of water going out must equal to the rate at which the water sold the accumulator. The best example, it is a simple idea. Input water is equal to the output water plus sold water. It is an important one to calculate the groundwater balance as well as water availability in the presence of an each and every reservoir. Next we see about the steady flow. Steady flow is defined as the groundwater condition remains constant with the time. In hydrology, steady flow means water characteristic light, velocity, depth and discharge at any given location do not change over time. The amount of water passing a specific point remains constant even though the water itself moving. What are the main characteristics of steady flow are water flow does not change, water table remains constant as well as discharge is directly equal to the discharge. What are the application of this force are water supply planning, groundwater analysis and mainly used to artifact design. Next we will see about the unsteady flow. Unsteady flow means the groundwater conditions changes with time. Unsteady flow generally defined as the movement or groundwater characteristic like depth, velocity or discharge at a specific location changes over time. Automatically, water level rises or falls continuously. The main causes of unsteady flow are heavy pumping, rainfall changes, seasonal effect, and artificial recharge. The main characteristic of unsteady flow are flow changes with time, water table changes automatically, storage as well as increases or decreases depend upon the rainfall. Next we see that what is an example of unsteady flow. During the summer season, there is a more pumping of water should be take place. Automatically groundwater level decreases. During the time of the rainy season, automatically groundwater level increases due to the less pumping will take place. Next we see about the artificial recharge. Artificial recharge is defined as the adding of water into the ground artificially to increase the groundwater level, or otherwise artificial recharge is defined as the human process moving the excess amount of surface water like surface runoff deep into the groundwater to store the groundwater for future uses, or otherwise it is defined as the normal rainwater goes away as a runoff. Artificial recharge helps send back to the rainwater into the down surface. Why artificial recharge is needed? During the time of groundwater level is decreasing, artificial recharge are used to increasing groundwater level. Automatically more water pumped from the well as well as groundwater decreased. Rainwater get wasted by using the artificial recharge method. Groundwater automatically injected. The main advantage of this method for raising water table, reduce water scarcity, and improve sustainability. There are three common methods and used as artificial recharge. There are recharge pit, recharge well, filtration tank. In recharge pit, it is a small pit filled with stones and sands. Rainwater enter and directly move into the underground surface. Otherwise, it is a defined as a shallow and excavated holes in the ground filled with permeable material like sand that allow the water to naturally filter and stored or sink into the underground surface. Next we see the recharge well. It is a water directly sent into the deeper layer with the help of the aquifer, or otherwise it is a defined as the deeper vertical load, and automatically channel is utilized for filter the rainwater and it is allowed to move downward on the down surface. A benefit into the increase the groundwater level and reduce the water shortage for dry weather condition and improve the water quality as well as support the agriculture. We next to see about the rainwater harvesting in urban and rural area. First of all, what is meant by rainwater harvesting? Rainwater harvesting is a simple and sustainable process of collecting, filtering, and storing of rainwater for the future use before it became runoff. And also, it is a collection and storing of rainwater for future use or groundwater recharge. Mainly, it will reduce the soil erosion as well as recharge groundwater levels and provide reliable backup and water supply. In a rural area, some techniques should be followed. First of all, farm pond. Creating a small, medium-sized check dams or farm pond across the local area to in terms of rainwater storage purpose during the time of dry season it will be utilized by irrigation purpose. Next we see about percolation tank. It is a large and open unlined tank that allow water to slowly into the down surface and raising the water table for surrounding as well as in the agricultural area. Next, we see about the rainwater harvesting in urban area. It is mainly used for water saving as well as groundwater research. Some of the techniques should be followed. First of all, rooftop rainwater harvesting. Mainly collect rainwater from the roof. Otherwise, during the time of the rainfall, it can be collected rainwater from the top of the roofs by means of pipes and into directly storage by the help of storage tank, and it can be storage water, can be useful for non-potable purposes. Next we see about the recharge wells, capturing the runoff from the parking lot, and this water is directly allowed to the shallow underground pit to recharge the local aquifer. After that, it can be useful for dry season. Next, we see about what are the benefits. First of all, save drinking water, reduce flooding, as well as automatically recharge the groundwater level. At the end of this unit, students are able to understand and apply the concept of groundwater and management.